Hi, I'm Cheryl Shamo, Application Engineer at Advantech. Today I'll be introducing our Edge AI Suite product line. This presentation will help you understand the relationship between Edge AI Suite and Intel's OpenVINO, and how this product offering can accelerate your AI application deployment. The edge-based solution requires more attention be placed on software and hardware integration, and will be the main focus of our topic today. Edge AI is a keyword that has become very popular. According to ABI research, shipments of devices with Edge AI capabilities will grow 15 times to 1.2 billion units by 2023. AI at the edge enables real-time decision-making without the limitation of bandwidth, cost, latency, and power consumption. To meet this trend, Advantech has developed Edge AI products and services. First, let's talk about hardware. We can provide acceleration modules and inference systems with various interfaces and computer power. And our software solution FaceView uses facial recognition for retail and access control applications. Now let's start to talk about the key subject, Edge AI Suite. Based on Intel's OpenVINO, we've developed and integrated this easy-to-use toolkit. Customers can adopt their own AI models to run inference programs on Intel CPU, GPU, or VPU chips. The software integrates the pre-trained AI models and optimized algorithms. This provides customers with a quick AI experience without requiring complex developing skills. We are currently focusing on computer vision applications, and eventually we'll develop advanced applications for transportation, manufacturing, retail, and medical imaging. Next, I would like to show you the benefits of Edge AI Suite. First of all, it's very intuitive and easy to use. With the integration of OpenVINO, it provides an all-in-one installer toolkit that can shorten development time. After the suite installation, we can directly launch an AI inference program with default pre-trained models. Edge AI Suite is a centralized utility that guides customers through AI inference operations and application scenarios. This GUI tool allows users to utilize the OpenVINO toolkit and observe visual results. This gives customers more time to spend on data collection and model training. On this page, we can see the architecture of AI Suite. From bottom to top, besides only supporting Advantech's hardware, it currently only works on Windows 10 operating systems. Using the OpenVINO toolkit, we can make model conversions from several common frameworks like TensorFlow, Caffe, and Onyx. We can apply the pre-trained models in IR format to inference libraries or programs. After successful conversion, we can use the inference engine to launch an application. We are working with third-party vendors to create even more advanced AI solutions. Edge AI Suite can be summarized into 4 important features: the integrated OpenVINO toolkit, pre-trained models with various frameworks, easy-to-use deployment tools, and domain-focused AI SDKs. Using the pre-trained models, Edge AI Suite includes both Intel and open-source samples for object detection, facial detection, and human pose estimation. The deployment feature provides verified conversion codes to customers. And the hardware monitoring function provides a graphic UI that can help customers observe real-time workloads and temperature of chipsets. Edge AI Suite includes an optimized pre-trained YOLO v3 object detection model that's popular in surveillance. We can sample the accelerated object detection in the Quick Start page and find the VPU usage in the System Monitoring page. VPU usage proportionately reflects VPU performance in frames per second. The graph on the left compares YOLO v3 inference performance for OpenVINO and Edge AI Suite. It's obvious that performance can be improved from 3 to 10 frames per second using the Edge AI Suite product. But the performance can be improved even further when it runs on VPU and GPU simultaneously. This simple flowchart shows how to quickly launch various model frameworks and visualize the results. First, we need to import the required model. For a non-Intel released model, they can be converted in the Model Launcher page. We use a showcase design to allow customers to choose the interested sample Then we can perform model translation to make the output model with the unified format. Finally, the rebuilt model can be used by inference programs. And a pop-up window is created to show real-time inference results by CPU, GPU, or VPU chips. Through this brief introduction to Edge AI Suite, we hope you can enjoy the benefits of our AI-focused products and services. Our acceleration modules and inference systems come with Edge AI Suite, enabling AI inference on edge devices. Now I'd like to introduce to you my colleague, application engineer Benson Cho. He will be demonstrating the hands-on portion of this presentation.
Hello everyone, I'm Advantech's application engineer Benson. In the next few minutes, I will introduce hands-on demonstration of Intel OpenVINO and Advantech's Edge AI Suite. In Advantech's AI system, left-click on Edge AI Suite on the desktop and open File location. Edge AI Suite has been integrated with OpenVINO 2019 R3.1, so you can also find OpenVINO's folder within. Then let's move to Deployment Tools, Open Model Zoo, Tools, and Downloader. Open one command prompt and go to the path of Downloader. Execute the model downloader of OpenVINO. Along with the parameter --print all, it will list down all the open source models which are available in OpenVINO. If you find any certain model that you would like to get, you can change the command parameter to --name with corresponding model name. Hit enter and it will download the target model automatically. In AI industry, many developers might already have the pre-trained AI models in various frameworks. OpenVINO has the capability of translating this pre-trained model into a compatible format. In Deployment Tools folder, you can find a Model Optimizer. It helps to translate pre-built models into the format that can be accepted by OpenVINO. In this way, retraining model is not required. We have already downloaded YOLO v3 object detection model from TensorFlow. Next, I will need to translate this model into OpenVINO's format. So let's go to Models path first. With Model Optimizer and the corresponding parameters, I will run the translation programs here. All the associated parameters can be found in the README file. Hit enter and wait for the process to complete. These parameters should be modified based on different pre-trained models. For example, here I am using object detection model, so the related download program should be Model Optimizer of TensorFlow. Also, I need to enter the path and the configuration of the model. Translation format is FP16. This format is determined by the device during the inference execution. You can refer to the website of Model Optimizer for other parameters. When the process is complete, there will be success messages and show you the file path of translated model. Next, let's run the inference program. Inference program is developed based on different scenarios. OpenVINO also provides lots of sample codes and examples for the developers. Sample codes are located in OpenVINO's folder. You can find them in Deployment Tools, Open Model Zoo, and Demos. Today, I'm going to demonstrate the inference program of object detection model from YOLO v3. In the prompt window, I will go to the directory and compile the inference program. After compiling, execution file can be found in the folder Documents, Intel, OpenVINO, Open Model Zoo Demos Build, Intel 64, and Release. So let's move to the Release folder. Firstly, execute the inference program with -h to show the help page. It will list down all the parameters that I'm going to use. Parameter -i is for the path to video. -m is for the path to model. -d is for the target device which will execute the inference program. Select one of the media sample from Edge AI Suite as the input video. For AI model, I will use the object detection model that I just translated. Select CPU as the device. Hit enter and the AI inference program is running successfully. Also, OpenVINO inference engine is able to run programs on multiple devices simultaneously. For the target device parameter, I change it to multi and use CPU, GPU, and the Advantex Vega series product. In normal circumstances, AI inference is running along with other background applications. To lower CPU usage, we can run AI inference on GPU and VPU only. In this way, CPU resources can be assigned to handle inference program threads or other tasks. Because inference programs from OpenVINO are just simple codes, the main purpose is to help users understand how to use inference engine and the execution results. Therefore, there still exists lots of rooms for improvement. With further development and optimization, there will be huge differences between the performance of current program and the enhanced ones. From the demonstration of OpenVINO, you can find it easy to download AI models of different frameworks and translate them into OpenVINO's standard. This helps to accelerate AI computing and simplify application development. In the next session, I will introduce Advantex Edge AI Suite. Firstly, let's run Edge AI Suite on the desktop. On the Quick Start page, there are a few testing examples. Only with a few clicks, it will show you the inference capability of Advantex Edge AI Suite. Select one of the model on the left, and the related information will be displayed in the next column. You can either select one local video as the input or the camera as the input. Lastly, select on which device you like to run the AI inference. Here, I select the CPU as the target device. When AI inference is up and running, switch to system monitoring for the usage status of each device. Here, you can see CPU loading is high, while inference program is executed upon it. For another test, rerun the inference program on VPU this time. Then switch to system monitoring. In this case, CPU loading is reduced significantly and the frame per second is improved because of VPU's add in computing acceleration. YOLO v3 is popular in the industry, and many applications of surveillance and management are developed based on it. Next, let's take a look at the instance of interactive face recognition. This application is able to catch and conclude information about the detected human faces such as gender, age, emotion, and so forth. A lot of small retailers now are integrated with this kind of solution. This toolkit also has an example of human pose estimation, which implements action recognition and prediction. It is suitable for the applications of public security and home care. For model translation, Edge AI Suite has GUI for quick deployment and user experience. In Model Launcher, you will find lots of open source AI models on top. Now, select one of the models for translation and inference. Click on Translate and wait for the process to complete. After that, click on Inference, then you can see the inference result in a few seconds. Besides Caffe framework, we also provide Onyx and TensorFlow as the translation examples. For more details about the parameters of model translation, you can go to Generic Models in Model Launcher folder. Inside this folder, all the commands and the parameters are listed in the README file. On System Monitoring page, in addition to Usage Monitor, Edge AI Suite also has a benchmark functions. It can test the performance of each processor on the system. Click Run and wait for completion. From the result, we can have some basic ideas of the computing power of each device. Okay, if you are interested in learning more about this product, please don't hesitate to contact us via the email below. Thank you for your time.